Assalamualaikum viewers. Today I will explain the units of equilibrium constant Kc. We know that different parameters have different units. For example, the unit of mass is kilogram, the unit of time is second, the unit of acceleration is meter per second square, the unit of velocity is meter per second. So all the parameters have different units. Kc is the equilibrium constant and it has no fixed unit. This is the very important point. No fixed unit like other units like mass, velocity, density, viscosity, etc. There is no fixed unit of Kc. The second point is Kc have no unit if number of moles of reactants and products are equal. I will take the example in order to verify this statement. H2O plus CO give us H2 plus CO2. In this reaction, number of moles of reactant are 2 and products are also 2. If we write the Kc expression for this, Kc is equal to concentration of H2 into concentration of CO2 divided by concentration of H2O into concentration of CO. This is the equilibrium constant expression. In order to derive the units of Kc, I will put the unit of concentration. For example, H2 square bracket mean concentration. Concentration unit is mole per dm cube. So we will write Kc will be equal to mole per dm cube. Similarly, CO2 mole per dm cube divided by mole per dm cube into CO mole per dm cube. We will put the unit of concentration. This mole per dm cube will be cancelled with this. So Kc have no unit. If number of moles of reactants and products are equal, we can write without calculations, without measurements, Kc have no unit because number of moles of reactants and products are equal. But if number of moles of reactants and products are different, give us 2NH3. This is a very important application for measurements of units. To determine the units, we will write the Kc expression for this reaction. Kc will be equal to concentration of NH3 power 2 divided by concentration of N2 into H2 power 3. This is the Kc expression. Now we will put the units of concentration. Kc will be equal to mole per dm cube square divided by mole per dm cube into mole per dm cube power 3. Or we can write it Kc will be equal to mole per dm cube square divided by mole per dm cube power 4. We will add the powers. 3 plus 1 is equal to 4. Now we will cancel the powers. 2 cancel with the 2. And finally, Kc will be equal to 1 over mole per dm cube square. How we will solve this square? We can write it Kc will be equal to mole minus 2 and dm plus 6. You know that in denominator mole square dm minus 6, it will become mole minus 2 dm plus 6. And after this example, we can calculate the units of Kc for any reaction. So the basic point is, first of all, we will write the Kc expression. Kc will be equal to concentration of products divided by concentration of reactants. Then we will put the values of or units of the concentration mole per dm cube. Then by solving this, we can solve or we can determine the units of Kc by using this method. After this, I will explain the equilibrium constant expressions. There are 3 equilibrium constant expressions. Normally, we are concerned with the Kc, equilibrium constant expression in terms of concentration. But there are 3 more equilibrium constant expressions: Kp, Kn and Kx. I will explain one by one. A of A plus B of B give us C of C plus D of D. If reactants and products are gases, we can use Kp. So Kp will be equal to P of C power C, P of D power D divided by P of A power A into P of B power B. This is the equilibrium constant expression in terms of partial pressure. Simply, we will replace the square brackets by the capital P. If we want to express in mole fraction Kx, we will write x of C into C, x of D power D divided by x of A power A into x of B power B. X is the mole fraction. And if we want to write the Kn in terms of number of moles, I will write Kn is equal to n of C power C, n of D power D divided by n of A power A into n of B power B. This is all about the equilibrium constant expressions in terms of partial pressure, in terms of mole fraction, in terms of number of moles. The second point is relationship between Kc and Kp. The first relationship is Kp is equal to Kc into RT power delta n. Kp is equal to Kc into RT. R is the constant, T is the temperature, delta n. What is the delta n? Delta n is equal to number of moles of products minus number of moles of reactants. So if number of moles of reactants and products are equal, then Kp is equal to Kc. This is objective point. Under what conditions Kc and Kp are equal? So if the number of moles of reactants and products are equal, then Kp become equal to Kc. Similarly, the relationship between Kx and Kp is Kp is equal to Kn into P over N power delta N. Delta N is again number of moles of products minus number of moles of reactants. This is the relationship between Kp and Kn. And the last relationship is Kp is equal to Kx into P power delta N. Simply for multiple choice questions, we should know that what is the relationship between Kp and Kn, Kp and Kx, Kp and Kc. In all these three cases, delta N is equal to number of moles of products minus number of moles of reactants. Thank you.